As usual, please look for the tasks to complete for today. This is Unit 2, Lesson 2. Do I have that right? Sorry, all my classes have different numbers now. Unit 2, Lesson 2. So again, you want to go to the Sci2C homepage and either look in the weekly calendar or look under assignments for tasks for U2L2. As we've been doing, I'm just going to throw us into breakout rooms for a quick little introductory chat. Say hi, check in with whoever you're partnered with, and then answer this question. Here comes Augie. Okay, here's the question in the chat. If you could live anywhere on this planet, where would you choose to live? You guys haven't answered this before, right? Okay, if you could live anywhere on this planet, where would you choose to live? I'm gonna give you 20 seconds to think about it, and I'll throw you into breakout rooms. All right, we'll come back together in 2 minutes. Rooms are open.
Upside down and inside out, and you can feel it. Upside down and inside out, and you can feel it. Don't know where your eyes are, but they're not doing what you said. Don't know where your mind is, baby, but you're better off without it. Inside down and upside out, and you can feel it. Don't stop, can't stop until you feel it going down. I wish I had said the things you thought that I had said. Gravity's just a habit that you're pretty sure you can't break. So when you met the new you, were you scared? Were you cold? Were you kind? Yeah, when you met the new you, did someone die inside? Don't stop, can't stop, it's like a freight train. Don't stop, can't stop until you feel it going down. Don't know where your eyes are, but they're not doing what you said. Don't know where your mind is, baby, but you're better off without it. Looks like it's time to decide. Are you here? Are you now? Is this it? All of those selves that you tried, wasn't one of them good enough? 'Cause you're upside down and inside out, and you can feel it. Inside down and upside out, and you can feel it, feel it. Don't stop, can't stop, it's like a freight train. Don't stop, can't stop till you feel it going down. I wish I had said the things you thought that I had said. Gravity's just a habit that you're pretty sure you can't break. Upside down and inside out, and you can feel it. Don't stop, can't stop until you feel it going down. Upside down and inside out, and you can feel it. Don't stop, can't stop until you feel it going down.
Gah! Is that what your back is saying right now?
All righty. So how many people have heard of OK Go? Not many. They're kind of an older band. They were very popular when I was in college. They do a lot of really cool music videos. So I'm going to split you into breakout rooms to discuss this, but just really quickly, let's state the obvious. What did you notice about that music video? It was a little unusual.
Their gravity is really
Their
weird.
gravity.
Yeah, they're floating around. All the objects are floating around. Very cool. At the end, they had water balloons full of paint or something like that. So clearly they are in zero gravity, and they mentioned that in the beginning of the video. And they're also inside what? Like, it's pretty obvious that all of this was filmed inside of what thing?
A plane.
But notice, so there's no CGI. I can guarantee you there's no CGI or wires in this video. There also didn't look like there were any cuts. And the video is 3 minutes and 21 seconds long. So here's the question. I threw it in the chat. I'm going to throw it into breakout rooms. And I'd like you to answer this question really quickly. How do you think this video was made? How did they manage to experience zero gravity for 3 minutes and 21 seconds? I'm going to recreate the rooms here. So you're with somebody different. Okay, we'll come back together in 2 minutes. Do your best to answer that question. Go for it. Kind of cool, huh? I can't imagine what this must have cost to make this video, but I assume they made it up when the number of flights they had to go on and stuff. Thomas?
Wait. My Ed puzzle didn't work, so I just watched it on YouTube.
Yeah, that's fine. Yeah, I think you and a couple people. This one, for whatever reason, it always freezes after the first question. I've had a couple of students that happens to them. Joseph?
I finished the first 4. I have the last one unfinished. So do you want me to just finish it up after class?
Yeah, no, it's okay. You don't have to. This is just a class activity. This one isn't graded, so it's not an assignment or anything. Yeah, this was just for fun, so don't need to worry about it. So as the plane is rising, it's essentially throwing them into the air. And that's why they're experiencing this double gravity, because you have to imagine that if you're just, all of you right now are sitting or standing, you can feel gravity pulling you towards the center of the earth, right? You're weighing on your chair, you're weighing on the floor. Now imagine if the floor suddenly started to rise upwards, to push you up into the sky, you would experience about twice as much gravity, and that's what they're experiencing in this airplane. But then they cut the engines, they go over this parabola, and suddenly they're all weightless, right? They're in zero gravity is what they say. And that's because they are suddenly in what with the airplane? What are they and the airplane and everything doing? Very good. I see everyone doing this. Bowling. Yeah, they're in free fall, right? So it'd be the same thing as jumping out of an airplane with a parachute, except they stayed in the airplane, and the airplane is now in a dive, and they're all falling together, which is why everything floats around, right? You call that apparent weightlessness. And then 2 times the gravity suddenly comes back as they kick the engines back on. The airplane essentially catches them, and then they start to rise up again. So you can see why they often refer to these planes as vomit comets, because all that change and movement and gravity coming and going, it makes you really sick. Most people are pretty prone to nausea if they go through this. And you can pay to ride on one of these things as far as I know. So I can't even read my own handwriting now with one of these. Oh, in terms of the waiting period, a lot of you noticed that, right? When they stood, sat, everything dropped, you could see those waiting periods that they kind of sped through. But here's the big takeaway. They keep saying zero gravity, and gravity fades in and fades out. Is that what's actually happening? It isn't. Gravity never changes. When you are this close to Earth's surface, you are always being pulled towards the center of the Earth. That never changes. There's nothing you can do about that because the Earth has mass and you have mass, and that's it. All they're experiencing is what's called apparent weightlessness. By being in a dive with the airplane, it looks like everything's floating around because the plane is falling and they're falling, and therefore they have no support force, right? Support force is that feeling of being on the ground, right? Things pushing against you where you're sitting or standing or whatever. So that's the key takeaway, that this is a complete misnomer when they say they filmed it in zero gravity. There's actually no such thing as zero gravity. That's a big misconception that exists in the world. As long as you have mass, you are experiencing some kind of gravitational force. So I think that's a big takeaway from this video. So who got it? What are the 2 reactions to being weightless? What are the 2 ways people respond?
Swimming and puking.
Yes, getting sick or swimming, which I think would be my reaction for sure too. It's like you're in water. And in fact, the motion, and if you've watched any footage of astronauts in space, and it's pretty cool to watch, it does look like it's in slow motion just because we don't have those kind of familiar jerky movements that we make when we're experiencing gravity in full as we evolved. And so it sort of paid off that, how did they actually film this? This is what really struck me. They showed you the video. When they played the music, what did they actually do to film it?
They slowed it down by like 28.75%, right?
Yeah, so it's almost like they're singing through molasses or something, right? And then they had to speed it up in the production. But again, it kind of helped that also did away with that sort of slow motion-y effect, even though you could still kind of see it in the video, but it did address it a little bit more. So I thought that was kind of cool. Anyway, if you're interested in this at all, they actually have a 20-minute documentary that they made all about how this was made, and it's pretty amazing. Some of the stuff they went through, they kept messing up because they wanted to do it in sequence. It's a pretty funny video to watch. I put it at the end of our task to complete list as part of the homework as an optional thing. Check it out if you want to. If you don't, it doesn't matter. But point of that is to emphasize that idea of weightlessness. Okay, so on that note, man, I wanted to use some slides to quickly review content from chapter 5 that you just read. Now I'm going to do this quickly because I'm assuming we're feeling comfortable with this. And it's pretty straightforward. It's stuff we're going to be building on later. Okay. Everyone seeing some slides in front of them? I'm going to need verbal confirmation because I'm going to blot out your...
Yep.
Awesome. Yeah. All right. So this is one of the challenges you're going to try. Center of gravity is really important. And so bending over and touching your toes is pretty easy when your center of gravity is sort of around your hips. But if you stand against a flat wall, it throws that off. And that's something you're going to try in a minute or two. So we're back to this equation, Newton's law of gravitational force. That's what F represents. Remind me, what's the relationship with mass? As mass gets larger, what happens to gravitational force? Does it also get larger or smaller? Someone shout it out for me.
Larger.
Bigger the mass?
Larger.
Yes, very good. The larger the gravitational force. What about distance, though? As things get further apart, does gravitational force get stronger or weaker?
Weaker.
Yeah, it's weaker, right? That's an important trend. So Newton slapped some math on this. And notice it is a force. And if you're familiar with forces from PSI, forces are measured in newtons. So where does that come from? It comes from a constant that Newton calculated. Based on basically taking, he took a 1 kilogram, or I don't know if he did it, but they figured this out somehow. They had two 1 kilogram weights. They set exactly 1 meter apart, and that is the gravitational attraction between the two of them. It's an extremely, extremely small number. It kind of shows you that gravity is actually a very, very weak force, unless you start looking at masses that are absolutely enormous, like planets and suns and stars. And then it can have a significant effect. But that is the gravitational constant G, where everything kind of levels out. And I'll offer an extra credit assignment where you can do some math with this. We already talked about the ear. Semicircular canals are what give us our sense of gravity, our sense of up and down, and our head motion. Don't worry about all this other stuff. That's all related to hearing, which is fascinating. But what's inside those semicircular canals is liquid. And you also have these basically ear stones, which are, it's sort of this like salty layer that moves a little bit more slowly when you move your head. And these hair cells can sense that direction of movement, and your brain interprets that as like we turned our head sideways or we got flipped upside down. It's actually really cool because this is also inspired technology in cell phones. I don't know if anyone's ever noticed, but if you take your cell phone and you turn it sideways, the screen corrects, right? It's not like you're looking at your screen sideways, the screen adjusts. And that's because they have essentially like a little pocket inside there that has a magnet that rolls around inside of it. And it's based off this exact same biological adaptation. They mimicked it in that technology, which I think is kind of interesting. Okay, this is the big takeaway from the chapter and everything we were exploring. Gravity doesn't change, okay? In this video, they were not experiencing zero gravity. They were just experiencing what's called weightlessness, which means that relative to themselves, everything else was floating around them. And I really like this elevator analogy. I think this is the helpful thing to do. That if you're standing in an elevator and it isn't moving, that's your baseline, right? I think they call it small g or something like that. If the elevator goes upwards, you feel heavier, right? The band OK Go was experiencing twice as much gravity as the airplane rose. If the elevator is going downwards, you'll feel lighter, And you might have noticed this if you've ever ridden an elevator before. You can kind of feel it going out from under your feet. If the elevator were to go into free fall, then technically you have zero weight or no apparent weight. That would be weightlessness, what they called zero gravity, but that's not actually the case. This is the exact thing that they were experiencing in their airplane. They were just in free fall with the container they were in. That's why everything floated around. Okay, you're going to do an activity today based on what's called center of gravity. Every object has a sort of central point where you could essentially balance that on a pin. It's where everything balances out. We're bipedal, and so we are constantly keeping our center of gravity over what's called our base. That's your feet, where your feet hit the ground is called your base. And any time that the center of gravity moves out from above the base, that's when you're going to fall over or trip and fall. And they referenced the Tower of Pisa in the reading. You had a homework question about that, but the Leaning Tower of Pisa has not fallen over because it technically has not gone outside of its the base, right? It's still actually balanced, and they have some counterweights on it now. But stability is all about that. It's about keeping your center of gravity above your base. So we're going to do a little Flipgrid activity to review this. This is the last task on the task to complete list. You're going to do a Flipgrid video where you're going to do two things. The first is that bend over and touch your toes thing. So bend over and touch your toes normally, then stand with your back flat against the wall and bend over and see if you can touch your toes without flopping over or having to stick a foot out to catch yourself. The other thing you're going to do is make a little balancing act. And I'm going to share my screen here for 2 seconds just to show you what I mean by this. But this is what you're going to try to do. If I could click on that tab. There we go. You're going to crisscross 2 forks, stick a toothpick in the middle of them, and rest on the edge of a drinking glass or a mug or whatever you can find. And if you get it just right, you can hit that center of gravity and you can make the whole thing balance. It's pretty cool. So there's instructions on the assignment, and I also have a little demonstration video you can refer to. So I'll give you what we have remaining of class time to get going on this. It is the Center of Gravity Challenge Flipgrid. So I'll time us for 15 minutes. See if you can get your video posted by then. And then we'll use the last minute to just quickly review the homework. Go for it. Let me know if you need help or have questions.